session, we have a couple of important things to cover today. First of all, some reminders. You know about the mock hackathon date now. You know the final hackathon date as well. So next week, basically, second session is your mock hackathon. And the main hackathon will be on 19th, which is Sunday. I will be sending an email with the venue as well. Second thing which is pending from my end is the link for the certifications and all the things that you need to know. So I'll be posting that information also. So keep an eye on that. Third thing, very important that we are going to do today is set up your data IQ accounts for the hackathon. So it's very important that you understand the process. And after those accounts are set, you will only be working on that for the next 2 weeks. So that will be your data IQ access. So we'll talk about what that option is. We will be doing a recap with Kahoot to discuss some of the previous concepts. And we will be doing a new algorithm today, probably the final algorithm of the module, which will be unsupervised learning. And the name of the algorithm is K-means clustering. So a lot of are there any questions that I can help anyone with? Anyone who has any clarity to be done for the module? All good?
So the 60%
Yes.
the maintenance.
So deadline currently stands 30th July, but I heard that extension till 5th will be a possibility for the perfect. I confirm that again and then so we are aiming, I think it should be possible.
Okay.
Yeah. Okay, now one important thing I want everyone's attention here. You will not do it. Just have a look here. This is again important from a hackathon perspective. Something that all of you should try later, not today. So just have a look. Yes, please. I'm recording. Yes. There. Please have a look here because this is quite important from the hackathon perspective. So you remember last we did decision tree and we looked at the credit card prepared and we did the training and testing. Anyone remembers what was one problem that we saw when we saw the confusion matrix? We observed there was one problem when we saw the confusion matrix.
100 something.
You remember the number? That's very nice. Correct. So out of the testing rows that we had for the test data, majority of them were yes as a prediction. And I said I could come up with a model and say everything is a yes. So then how do you tackle that? So we agreed to a thing, and all of you can have a look here. Please don't do this along with me. Just observe the steps whenever you get time. Do practice it because some of what I'm going to tell you now will be part of your hackathon. So the last column, which is signed up and analyze. Right. Those who came just now, you need not do it, but immediately just have a look at what we are doing. It's just about this. Something is disturbing there. All good. Yeah, please pay attention. Okay. So yeah, this original data, we had 318 people who did not opt for the credit card, and we had 2,682 of them who opted for the credit card. And this is where we decided that maybe what we can do is prepare a new where I know I take from guests and roughly around 800 kind of a data set. And then I do the training testing and then I do decision tree and all that. But the big question was how exactly do we form it like that? Give it an attempt.
Right.
All of you, let me remind you, you must be practicing. Is a week away, and if you're not practicing, not trying new things, then you're just relying on your luck on whether things can. Do remember, the majority of what you do in the hackathon will be what we did in class, but there will be elements like this, which you're whether you have actually done the practice or not. I want everyone to pay attention here right now. Don't do it on data IQ because I want you to try later. So don't repeat the steps. You'll get confused. What the options are, on what the recipe is, and then whenever you get time, you can try that later. What I'm going to do is I'm going to attempt to make a new data set where I retain all the nodes and select 500, around 500 of yes, and make a much smaller data set, which is a mix of yes and no. So let's see what are the different ways. Of course, you can find your own way. That's the beauty of data IQ. You can try all possible combinations. I would ideally, if I was new guy to data IQ, I would ideally use Claude and GPT. I would prompt and say, look, I've got a data like this, and I want to retain all the no's and sample out some of the yes. Tell me what recipes, tell me what steps can be useful, and then try and application one of the methods. Later, if you try a much simpler, but this is one method that I could figure out, which sounds more logical. So I click on the prepared data set. First, going to be my approach. So everyone, please listen. Don't do it, and this is very important. Don't do it because there are multiple recipes, multiple steps. Here is my strategy, and listen to the strategy very carefully. From this credit card prepared, I would separate out two data sets. One data set will have all those customers who did not sign up for the credit card. Another data set will have all the customers who signed up for the credit card. I repeat, I have this just like test and train. We had something in test, something in train. Similar to that, similar to that, I'll break this again into two data sets. One will have all the no's, one will have all the yes, separate data set. Take a guess. Which recipe can I use for that? Split again. And this is what I wanted you to understand. Split recipe is not only for training and testing, it's for splitting. Anything that you want, you decide the way you want to split. So let's have a look how I can further play with it. So I select this. I go for split. And now it says, okay, your input is prepared. Give me the names of what you want to split. Let's do that. So I would say one data will be called credit yes. And I'll create. Another data will be called credit no. As I said, please don't try because you will get lost in the journey. Have a understand the strategy. Then you take out your own time to try. So there is the prepared data set. I'm saying, hey, look, I'm going to divide it into two parts. One is going to be credit yes, one is going to be credit no. And I create the recipe. Now, can you take a guess? Define filters. That's the correct option. I don't want to randomly do. I don't want to map any values. I don't want the sequential splitting. So in filters, what I can do is whichever is yes in the last column, send it to yes data set. Whichever is no in the last column, send it to no data set. Let's try filters. So I go for filters and it says, which is your ultimate destination? It has started with credit yes. Can you tell me which customers will go to this credit yes? So those who signed up, right? So let's check what is the condition. Now, instead of customer ID, I would say signed up is true or false? Is true. Those who signed up, yes, should go in yes. Done. One split is there. I can add another filter. So there's an option called add filter. And now my location will be credit no. and you say those signed up credit, which is false, send it to credit no. Done. So this filter, what it will do is how many were there? 300 something no were there. All 300 will go to no. And I think what 2000 something, 2800 were yes. All 2800 will go to yes. My job is not done yet, but at least my start is there. So let me show you how it looks like. So I run it and I go back to the flow and you see what happened. Our old test and train is still here. Nothing has changed. I have given another split. There is a yes and there is a no. We would love to see if it achieved what it achieved. Let's click on yes. 2682 rows. And I can also verify. I go to the last column and see everything is yes. All the yes customers went in one data set. And let's see the other one, whether that was successful. This is no. And all the no customers went into another data set, which is 318. I can double check. I can go to last column. You see everything is no. Okay. Now I come back. So is my job done? What is remaining now? That's correct. You will have to take some samples from the yes. No is no, no problem. Once you take some samples from the yes, then you can add the no and then make it into one data set. But now the next question is, how do I take some random samples from the yes? Take a guess. Which recipe? Split will again result into two. I don't want two. I just want one. So this data set should do something that will lead me to another data set.
Join.
Sample, and this sample and filter. You see, there's one recipe, and now you intuitively start understanding. So, answer to the question, why not split? Because now I don't want two separate data set. I still want one. So, split will not be the perfect one. I'll go for sample and filter. So, it will say, okay, I'll take a guess and I'll create another data set, which is filtered version of yes, and I'm fine with it. And now I say I can choose the sampling method, like do I want first 800 or random and all that. Let's choose random and I will specify the approximate number of records. So I would choose random and I would say give me roughly around 500 from the yes. Okay. So I specify the number of records, I specify do it randomly. And remember, it is approximate number of records. So it might give you 510, it might give you 490, but roughly around 500, it will extract, which is what I want. And I can say done. That's exactly what I want. Okay, now I go back to the flow. There you go. You see what happened? One on one. So it took yes, we did a sample and we created another data set which has roughly around 500. We would love to see how many it has. Let's see, 534, which is good enough. Okay, so 534 and all these 534 should be yes. You see, all the columns are yes. So far, so good. Now I have got 500 over here and I've got 300 over here. My objective is to join them or merge them together. Okay. So now let's see, how do you intuitively understand which recipe to go for? There is a trick in data. Let me show you. Now what is happening is when I click on this, these options are for this data set. When I click on this, these options are for this data set. When I click on this, use a control key and click on this. I'm clicking both together. Now, as soon as I click both of them together, these options are applicable to two data sets. And now you can quickly search on GPT or Claude, is join a good option, fuzzy join a good option, any other option. And if you do that, it will tell you the best option to add row-wise data, not column-wise data. Remember, there are some rows in data set one there are some rows in data set 2. You're trying to join one after the other. The option is actually stack. This is what it does. It takes two data sets, just merge them together. So it will say, I'm taking this, I'm taking this, I'm going to create another data set, which is the merged version of this. And then you create that recipe. It will show you, do you want to change anything? I wouldn't want to change. I'll retain the original, just run it directly. And that's it. We have achieved our task. So you see what it did. It took your no directly into this. It took your sample of yes, combined it, and made a wonderful data set, which is around 800. Good combination of yes and no. And let's see how many yes, how many no. So total 852 rows. And if I click on analyze, there you go. That's the distribution. 318 no's and 534 yes. And now I can say, okay, this is assume my original data set. And now I would do testing and training on this. I wouldn't do 80-20 testing and training because that would leave very less rows for training. Here, I might prefer 90-10. So I would give more data for training, keep less data for testing, then run decision tree on train, then check, did I get similar accuracy or this time it failed? And that will tell you a true story. The model that you built earlier, was that good enough or was it just because it was biased? If you get similar accuracy now also, that means your model genuinely is a good predictor. And that's how we take care of biases. Okay. I'm not going to do it. This is something that you should experiment. Try later, try all the recipes, check if everything works. And again, in hackathon, there could be very specific questions. So I could say, okay, do one thing, filter out all the customers who have a yes in their survey, and then do clustering on that. So if you don't know how to filter which recipe to use, you wouldn't be able to do clustering. So just make sure that you try all the recipes, you get comfortable with everything, and then just practice whatever we are doing in class. Okay, any questions on this? Okay, now let's get to something important. Setting up your accounts. This is going to be challenging, but let's do it. So number one, I want all of you to sign in to My Learning. And today we are going to set your Data IQ accounts for hackathon. And in My Learning, you'll see a section called Important Links. And in the important links, I have added a new link, which is called 14-day license registration link. And we will do this step by step, so be very careful. In the important links section, you'll see 14-day registration link for Data IQ. This is completely internet-based, not on our university server. Now, you please don't proceed to next steps until I tell you. Step number one, fill out this form. And in this form, it will not allow you to enter any other email ID other than the business email ID, which means now here in this form, you use your MDX email ID and fill out everything. So let's get started. I'll also do this along with you. Use your MDX email ID. Just fill anything random in employees or everything. Just make sure the only important thing is your MDX email ID. If you put Gmail or Hotmail, which you will, but not at this point of time, you will not be able to proceed to the next step. So make sure that you're using MDX email ID. And once everything is done, yeah, sure. I just entered my email ID. That's it. Just put your MDX email ID. Everything else is not relevant. Put anything. Sales, marketing, number of employees, put anything. Does not matter. And click on start free trial. And stay on this screen. Don't enter anything here. If you successfully reach this screen, that means you're good. Don't enter anything at this point of time. Just keep your screens ready so that I know enter your captcha, whatever. Yeah, that's what you're getting. Sorry, anything. Just MDX email ID to begin with. Okay, most of you have reached. Just keep the screen ready, this one, so that I know. Once you have reached this screen, it will again ask you for email address. Okay. Now be careful. In your second screen, when it is asking you the email address, that's going to be your personal email ID, which is Gmail or whatever you use, Hotmail. You enter that and press continue. Do not enter MDX ID because the code will not reach Middlesex ID. Now use your personal email. If you have a Gmail, Hotmail, or whatever, then enter that and press continue. And it will say, if you press continue, it will say a code has been sent to your personal ID. Use that code, enter there and get inside. Let me know if anyone is still online, otherwise I'll assume you're with. Yeah, so just refresh, wait for the code. Once you enter the code, it will prompt you to this screen where you can set up your own password. And this is your responsibility. Do not forget the password. This is going to be the password for your hackathon account as well. So carefully set up a new password for your account. The username will be your personal email ID. Which email do you put? Personal only, right? Got it? Check the spam also in case you haven't. Are you doing with us, right? Yeah. Yeah. Okay. Fine. Once you set up your password, just enter the other details and continue. And we'll see. Yeah, stay on that screen. Yes. Okay.
What was happening?
Which one? Oh. Yes, stay on that screen. Stay on that screen. Yeah. Okay. Okay, and at this point of time, Dipayan, let me check 1 minute. Yes, Dipayan, that's exactly the kind of screen that you should be receiving. Also, those who are online students right now, can I request anyone to volunteer to show your screen? Because yours is first registration, so I can take that as an example and tell you the next step. So can you raise hand if anyone can volunteer? I'll just give you the presentation rights. And Alicia, thank you. Okay, so I'll just make you the presenter, Alicia. And if you can share your screen, I can
Yes.
then guide everyone according to that.
Okay, okay. Yeah.
Sorry, Alicia. There you go. Make a presenter. Okay, done. Alicia, I've made you the presenter.
Okay, so I'll just share.
Yeah. All right. So everyone, please have a look here. First of all, can you confirm if anyone is not able to see the screen? Let me know if anyone needs any help. So all good so far. When you filled up the form, you gave your MDX email ID. It took you to the next screen where you gave your personal email ID. So remember, for your login, personal email ID will be your username. Yes. Just write it. What is it? All good. Also one more thing, just like Data IQ, which you were using, the MDX version, I would always recommend Chrome as the browser even for this. Do not try any other browser. Okay. Now that you're on this screen, it says choose a region and then a name of the space. Okay. So very important for you to understand what is that region. That region is not something that where you are currently. So generally starters make that mistake and they search for UAE. That's not the thing. That region actually is asking where should the server come from, which means which country should be the host server. I would say retain the original one. US is good because it is far away from the place, but then with all the stable latency and rules and everything, you can choose the default version. And in bracket, if you see, it says AWS, which means actually your server is coming from Amazon Web Services. So it's a server given by DataIQ. It's not related to Middlesex. So far, you were working on Middlesex server, but now for the hackathon, it's an independent server which is coming from Amazon Web Services. So do not change anything. Whatever is, choose the region. That is good enough. You whatever and AWS. There is a default name given to your space that also you need not change. So don't change anything. Click on create my space. So just click on create my space and you will get inside the official platform. And you should see something like this. So just stay, wait. By the time you land on this screen, you will see that your free trial plan will expire on July 23rd, which is good enough because 19th is your final hackathon. So you will be able to use this account all the way till 19th. So you will use this account for mock hackathon, you will use this account for the main hackathon and everything. The only thing you have to be careful about is what actually happens and what you see right here. It is powering on the instance, which means it is switching on a machine that can help you work on Data IQ. So sometimes when you log in machine might be switched on automatically, so you then need not do anything. Just click on open instance and get inside data IQ. If the machine is switched off, then you can switch on the instance, which will take probably 30-40 seconds. And then once it is on, you can click on open instance and it will take you inside data IQ. So if I may ask, how many of you are already getting the option for open instance? All good? You're getting it? Click on
Excuse
open
me,
instance.
sir.
Yeah.
I'm so sorry, but I couldn't
Yep.
catch you for what needs to be put in choose a region and space name.
Just same, nothing. Don't change anything.
So I don't have to change anything and just click on create my space.
That's it. That's it.
Okay. Yeah, thank you.
All right. Nawar, you can just refresh, please, and try again.
Sir, it's showing the same error.
Which browser are you using?
I'm using Chrome.
Sorry?
I'm using Chrome. Google Chrome.
I will ask you just one.
Yes.
So guys, have a look here. In my case, the instance was switched off. So I'm turning on the instance. So once you turn on, this will show powering up the instance and then you click open instance. How many of you are successfully able to go in? Can I see how does it look like? Hold on. It will take time. Yeah, that's fine. That's fine. The first one takes time. Yeah, you can click on open instance. Yeah, so once you are able to click on open instance, it will ask you some questions, blah, blah, blah. Do you want to use it? And give it those answers. Click next, next, or skip if you want to. That does not matter. Just do next, 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 next. What's the message there? Yeah, that's right. Just click next, next, next. And, sorry, skip the questions not relevant. That's fine. Ignore the message that you're getting on top. That's fine. No problem. If you want to answer the questions, else just skip. Does not matter. It's not there. Sorry. Skip tutorial. You only need. And once you do that, you should be able to see a new project option, and then everything is the same as the previous one. Thank you, Alicia, for volunteering. Yes, that's the option that you see. Right? You see a new project option, and now there is no sharing space. It's your own project. Your project is not visible to others. Others is not visible to you. So you can create as many projects as you want, but keep in mind this will retire after 14 days. So whatever you do will be deleted after 14 days. It's mainly for your hackathon that you need to use. Yes. Sorry. For what? Yeah. So even so, data there for other data can also be used inside. Okay, I'll share my screen now. Thank you, Alicia. Okay, my instance is running. I'll click on open instance. So I'll click on new project. Everyone can make a project and give any name. And once you create a new project, then it's pretty much the same. If you have to upload your data, you can just click on connect or create, and you should be able to see upload your files. That's where you upload it, and then you're back to the flow. Let's actually upload one. So let's bring that last downloaded data, credit card sign up, let's say. And then you're back to ground zero. This now you already know. So there you go. Flow, everything is the same. Recipes are the same. Everything is. Just create any random project, just upload any data set, just to make sure. I'll give you 5 minutes to get used to this. What we will also do right now is we will log out and log out of this, try and log in with a proper URL, but that a bit later. So right now, just get comfortable with the back arrows. You see all your projects will be listed here, and these will only be your projects. You wouldn't see anyone else's project. Again, if you want to create a new project, you can, or you can just click on the recent project and get inside. Just click on connect OK, upload files. Upload your files. If you're doing it for the first time, it might give you some suggestions of a tutorial to see or that next. Just make sure that you can make new projects. You can come back to your existing projects because you're going to use this for the hackathon. Online students, Dawar, are you still facing that error?
Yes, I'm still facing
Okay,
it.
can you share your screen, please?
Just one moment. Just, okay.
Yeah, just enter your email address.
Yes.
Okay.
I'll just enter this and continue. Then I'll receive a code. One moment.
Yeah.
59603. Now here I can
You set
add
up,
my
yeah,
own.
your own password, right?
Yes. This doesn't matter really. I think
Yeah, it
you
doesn't
can
matter.
write. I'll just write it. Okay, so it's already in use.
Okay, so then what you can do is, let me tell you, 1 minute. So I'll share a link in the chat.
Yes.
Just click on that link and enter the username and password directly there.
Okay. One moment. I'll use Chrome.
Yes, please use Chrome.
Yeah, see, it's showing me this error.
Even for the launchpad. Okay, can you do incognito mode? Just do click on the 3 dots, yeah, and try the link now.
Hmm.
Is it something about your Wi-Fi connection that restricts?
I mean, I'm not sure really.
Could be. So just try. Maybe there is something with the firewall that is blocking it. So just make sure that try it with, let's say, a hotspot for you from your phone, and then see.
I'll give it a
It's the
shot.
Wi-Fi, nothing else. Okay, now everyone, let's have a look. So what I'm going to do is I'm going to set up a launchpad link. So now what I want everyone to do is just log out from your account so that you know when the hackathon starts, where to go in, where to enter the username and password. So everyone, please log out from your accounts. And I will also do that. So top, you see extra right, and there you see, once you click on your name, you see profile and settings, and here is a sign out option. So just sign out of your account. And then what you should do is to make your life easy, come back to my learning, and in the important links, I would rename this 1 minute as 1 minute, Launchpad Data IQ. And I'll also put hackathon so that you're clear this is for hackathon. So I've renamed the link as Launchpad Data IQ Hackathon. Just click on that. It should directly take you to the place where you can enter username and password. If you're already signed in, then it will not ask you again. If you are signed out, then it will ask you username and password. Just enter your username, enter your password, and you should get inside directly. So this is what you're going to do for the hackathon. Just click on this launchpad, enter your username and password, get inside, and you should see the open instance. All good. Everyone is good. Once you see open, just remember your password. Please make sure that you have chosen a password which you remember. All good. Same. Now MDX is no longer required. So your username is your personal email ID. Password is the password that you use. And every time now no longer MDX email ID, it's just your username and password. Okay, one thing that I want you to check, everyone, please stay with me. Let me know if you have this feature or not. Okay, first of all, question, anyone not reached this stage where you can click on Launchpad, you can enter the username and password, and you can get inside. Is everyone comfortable with that? Okay, all right, next. Tell me which data set did you import just to test? Okay, whatever you have imported, I want you to check something now. Please, everyone, check if this feature is by default switched on, or do you need my help to switch on that feature? So, whatever data you have imported, click on that and click on prepare recipe. Okay, and give it a new name and enter inside prepare recipe. Have all of you entered inside prepared recipe? The feature that I want you to check, which is the most mind-blowing feature, and we'll use that later, is now do you see generate steps? Do you see how many of you see generate steps? How many of you don't see? This is the AI feature that I was talking about, where you can enter the prompt here itself. I suppose all of you should not be seeing the AI feature. Okay, so
I don't see it.
generate steps. Do you see this just below add new step? You don't see, right? Now I'll enable this for all of you. So please take note. First, let me show you what is this generate steps. So if you click on generate step, there you go. The prompt appears inside data IQ. So you can actually say, let's say, yeah, so we can do this shopping interest. We can do something simple as of now. Let's say number of children. So replace, let's try this. Create a new column named child. If children column value is 0, then child value should be no, else yes. Have a look, guys. I don't know if you observe what I did right now. So I just wrote in the worst possible English ever. I said that make a new column called child, and wherever children values was zero, make it no, else make it yes. I just clicked done.
Hello?
And I already created a new column all on its own, purely by the English prompt that you are writing here. So that's how the prompting is more intelligent. So now you don't have to worry whether GPT is giving you the correct formula or this and that. You can put your requirements here. You can also do your missing value, average, mode, and all that without knowing where the options are. You can just describe in plain English. But let me tell you, how do you enable this? So let's go to the settings and make sure you have this AI feature. So right on
Hello,
top,
sir. Can you
sorry,
hear me?
yes,
Yes, I can actually access it now. It's
okay.
because I used a VPN. Now it's working.
That's the thing. Yeah, makes
Yeah.
sense. All right.
Okay.
Okay, so everyone, let's have a look. Right on top, you see that grid icon. Just on top right, you will see all the settings of your data IQ. Once you click on the grid, I want you to click on administration, which is where all the settings are. So click on administration. And you see all these options where you see security, code studios, monitoring. The last option is settings. Let's go to settings. And in settings, the first set of options is user experience. Can you see that? Yeah. Inside user experience, there is one option called AI assistance. You don't have that?
Can't see that, sir.
No, sir, we don't have it.
Oh, that's the big one. Okay, so click on AI. Yeah. Yeah, enable. Agree. Operation. No, that's right. So, but this is your own. So. You're there. This is a transition of a cloud based. I have read. So guys, for this, I will check. I will also register with a new account. Maybe they moved the options somewhere. So if you do not find the AI assistance right now, I'll figure out where the AI assistance is in the new version. Probably they changed. And this is all cloud-based. So whatever changes they are reflecting, you will see the changes here. Mine is an old account, so I haven't set up a new one. I'll set up a new one. I'll figure out where they have moved this and then find a way where I
Sir,
can enable that. Yes.
sir, I can see the AI services on the
Yeah,
top
that's different. No,
navbar.
that's different. AI services is on top, yeah, but that's more on the LLM feature. I'll check that.
Okay.
I'll check that. No worries. Okay, so other than the AI assistance, everything okay? Is everyone comfortable now with the launchpad and the username and password? Make sure it is your personal email ID and remember the password. The main MDX data IQ will be disabled during the main hackathon. So please make sure that you have these accounts set up so that you can complete your hackathon inside your personal space. Okay. Correct. Not always. So sometimes when they switch off the instance, so usually I think after 9-10 hours of inactivity, if you haven't done anything, it switches off the instance automatically. So then you open, I mean, you click on turn on instance, then click on open instance. If it asks you to, if it is already logged in, you're good. Personal email ID. Now, no longer MDX email IDs. Always personal email ID and password. Yeah. Go back here. No, that's, I will figure out where that is. Currently, they have moved that out. Okay. All right. Let's do a quick recap and then take a break. And then once we come back from the break, we will do unsupervised learning. And we will do unsupervised learning inside this one, not the MDX thing, so that you become comfortable. And we use this for the next 14 days. All right, quick recap of supervised learning before we move on to unsupervised learning and explore a new algorithm today. Has everyone scanned? Shall we get started? Okay, let's start. Give me the QR code again. Shall we? All right, let's start. Few questions just to recap whatever we have seen so far from algorithms perspective. All right, here is question number 1, 7 questions. If you test the machine learning model with trained data, what would be your accuracy? If you test the machine learning model with trained data, what would be your accuracy? 0, 50, 100, unknown. Oh, interesting. You already got it right, but I need an explanation. Why 100? How do you get 100% accuracy? You trained using that, and that's what machine learning model is supposed to do. It will work on the model. It will give you 100% accuracy. So if you test it back on the trained data, it has to be 100% accurate unless you change something in the model setting. So it's always going to be 100%. Good job on that. Let's see top 5. Varun, Naman, Pratap. Okay. Moving on, Q2. If you test machine learning model, data, what would be your accuracy? 0, 100, 50, anything between 0 and 100. If you test the machine learning model with test data, what would be your accuracy? Thank God. I was thinking that people will get confused with the other things. Five of you said 100%. Absolutely not. You don't know what your test data is. This is just a generic question. If you test it on the test data, it can be as low as 0. It can be as high as 100. It could be anywhere between 0 and 100. So thank you for that. Majority got this right. Anything between 0 and 100. Oh, it changed. Sam? Okay. Q3. What is the rule of thumb for splitting train data and test data in machine learning? This should be fastest fingers first. 50-50, 100 test, 0 train, 20 train, 80 test, 80 train, 20 test. What percentage goes in train? What percentage goes in test? All the chocolates are pending, by the way. I'll correct everything. I have recorded it on Kahoot. Yeah, this is nice. Thank you. 80% train and 20% test. Definitely easy one. Bhargavi is number 3. All right. Okay, moving on to Q4. Question number 4. Regression is an example of AI, machine learning, supervised learning, all of the above. Regression is an example of. Now I thought there would be this confusion. Anyone who got this right has an explanation why? Anyone has a machine learning and it is supervised learning, but why do we say it's also AI?
So because we use regression in building AI model.
That's right, but there is even better explanation for that. I told you when we started the whole hierarchy, machine learning, yeah, if else, that is pure AI. But I told you that machine learning is part of AI. Initially, AI was happening with if else, if else, if else. Remember, again, everyone, please pay attention. Very, very important because you might go out of the module and say, oh, regression is not AI. Purest form of AI is if else, if else, if else. That's what humans used to do long back. Now AI has been enhanced with machine learning, and there are two types of machine learning: supervised learning, unsupervised learning. If someone is asking you that is regression still AI, 100%, it is an AI algorithm, but you cannot say it's a purest form of AI where only if else, if else, if else is working. So all what we are doing in this module, everything is artificial intelligence. Machine learning takes historical data and then learns from that. And then there are different types of machine learning. So remember the hierarchy. We start with AI. ML is a part of AI. There are two types of machine learning: supervised learning, unsupervised learning, and deep learning. And then there are some algorithms that do supervised. There are some algorithms that do unsupervised, some algorithms that do deep learning. Everything else, everything what we are seeing comes under the umbrella of AI. If the option was purest form of AI, then it was not. Regression is not purest form of because it requires historical data. So it is machine learning, it is supervised learning, it is also AI. So those who got it right were lucky with this question. Things would change. Ah, nice. Sam is on fire. Q5. R square in regression can be best defined as. Is it the error in regression model? Is it accuracy of regression model? Is it percentage fit between trend line and actual data? Is it the percentage of gap between trend line and actual data? How do you define R square? Oh, I thought this was an easy question. Okay, now let's have a discussion around this. I really want your input. Majority of you went for accuracy of the model, which is not wrong, but actually it is wrong. Why can't I say that R square is the accuracy of regression model? Uh, so if it is 90% and someone is saying it's 90% accurate, what's the problem? Not be 100% always, but if someone is saying the accuracy of regression is 90%, what's the problem? Everyone, please participate. It's a fundamental question. And you have to be careful when you use the words like accuracy. Let me explain. When we did sales prediction on daily data, okay, we got the equation, we got the R square. Now, when we got R square as 0.9 or 0.85, we never said that's the accuracy of the model. When do we say it is accuracy of the model? Please listen carefully. Imagine we are predicting it for day number 30. Okay. I put the value of X as 30. I get the value of Y. And I'm saying that's my predicted value. When I actually saw on day 30, I noticed what was the real sales. Now, if it matches, I would say 100% accurate. That was a good accuracy. But in R square, we never did that. We never went with the test data. We never said whether it actually matched or not. R square is not the accuracy of the model. It shows you how much trust you can have on the model so that you can take that equation for doing futuristic prediction. In fact, if you remember, R square was nothing but the gap or that gap that you saw between trend line and the actual data. The more closer trend line was to the actual data, higher was the R square, which means it was actually the percentage fit. If the trend line was exactly on top of the actual data, that means 100% fit. That means R square is 1. If it is 90% closer, that means 90% fit. That means R square is 0.9. The opposite of R square is the gap between the trend line, which means if 0.9 is the R square, you would say there is a 10% gap between the trend line and the actual data. So while it might look okay to use accuracy, that's actually a wrong word. Accuracy can only be used if you really tested it with the test data or with the actual outcome. Only then you said, oh, the predicted this, your answer was this, hence there is an accuracy or there is no accuracy. R square does not tell you that. R square only tells you how robust the model is, how much confidence you have in the model. Yeah, everyone. All right, still some changes. Dipayan, welcome to top 3. Moving on. Q6. Which algorithm can predict a categorical variable? Unsupervised regression, logistic regression, clustering. Which algorithm out of these 4 options can predict a categorical variable? This should be easy. Fantastic. Thank you so much. This I expected most of you to get it right. Can you tell me why not unsupervised? That's correct. You're still predicting one variable. It can be categorical variable, it can be numerical variable, does not matter. So unsupervised, you don't predict one variable. We'll see that today. Today we are doing unsupervised learning. There is no one variable that you're predicting. Clustering is also part of unsupervised, which you don't know, so you can leave out that option. Regression can predict only a numerical variable. It cannot predict categorical. That leaves out with the only option, which is logistic regression. And that brings us to the last question, Q7 of 7. For prediction, you put the value of x1, x2, x3, etc. in logistic regression. And then what do you get? Do you get y? Do you get probability of y? Do you get logit of y? do you get log of y? This is only for those who listen very, very carefully in the mathematical part. Otherwise, you get this wrong. Oh, I knew that. I knew that. I knew that. All right. First of all, majority of you said probability of y. You're not wrong in a way. Finally, when you put x1, x2, x3, you do get probability of y. But I would like to draw your attention once again to logistic regression. And let me show you the equation, and then you will understand what I'm talking about. You remember this equation? Minute. Okay, there you go. Now, if you remember what I told you, that if you put the value of x1, x2, x3, x4 in logistic regression, I told you that eventually you get probabilities and not the direct prediction. So most of you were right. But mathematically, if you see, what do you get when you put x1, x2, x3? You get log of probability divided by 1 minus probability. And this term, and please listen to all the terms. The term that you see, P divided by 1 minus P, is actually called the odds ratio. Okay. In maths, you call it the odds ratio. What are the odds of winning or losing a game? That is P divided by 1 minus P. Log of odds ratio is called logit of Y. And that's a mathematical term. So when you put x1, x2, x3, you don't get directly P. You don't get that. You don't get log of Y. You don't get that. You get log of odds ratio of the probability, which is called logit of Y, from which the tools calculate the probability for you. So again, if you answered probability of Y, you're partially right. You do get, eventually you get probability of Y, but first what you get is a mathematical term called logit, which is what is log of odds ratio, and the name logistic regression is derived from this mathematical term, which is called logit, and hence the correct answer was logit of Y, even though probability of Y is the most common accepted answer. One thing for sure, which it does not give, is Y. It does not directly predict whether someone survived or not. So the most closest answer would be probability of Y, but the correct answer is logit of Y. Okay, thank you so much for doing that recap. Let's have a look at top three. Dipayan, congratulations. Number three, Sam, congratulations. Number two, and who's number one? Lubna, where's Lubna? Online, all right.
Some online.
All right, well done, Lubna. Thank you.
Sir, online, sir.
Dipayan, definitely, I know. Okay. Let me take a screenshot. You're Sambit, right? Yeah. All right. Time to take a well-deserved break. It is 2:50. Let's come back at 3:05 and start with unsupervised learning. Thank you.
Hello.
but you want to do some project or something, should carry on. So
Okay.
you just make a call.
Uh-huh.
The laptop's pick it.
Okay.
You just tell them on the mobile like this will do,
Okay.
and by the time you come, you're
The process is done. That's interesting. There was something like this earlier, but that was more about using the system resources. So let's say if it is running idle, I can pre-plan and I can say, okay, now it's idle, use it for this, use it for that. But doing a particular task on call will be quite interesting. All right, everyone is back. Not yet. It's started. Just before I explain what is the new algorithm that we are going to do and what it does, maybe we can just get ready for data IQ. So I want you to download one file. You will see a folder, which is decision tree plus k-means. And the file I'm referring to is IRIS, IRIS. You would see a IRIS CSV file. So please download that, keep it ready. You can even open it in Excel and see what is in. So this. But, yeah. That's right. Yeah, correct. So decision tree essentially is meant for categorical. There is a version of decision tree which is called regression and classification. Regression tree. So not what it means. The one that we are using is only for category. Yeah. So just for your reference, it can be used for numeric, but it's a different variation of the tree. It's called regression trees. Regression decision tree, which can be used for numeric also. But from this module perspective, just consider category. Sorry, Ash. Or the trial mode. We'll be using it on the trial mode. Don't import it on data IQ yet. Let's have a look at clustering first. What is this algorithm? What are we trying to do? Okay, so brand new algorithm, completely different from what we have seen before. Different type, different learning, different purpose, and very different execution. Quickly, please. So far, what we have done is supervised learning. We started with regression. We went on to logistic regression for categorical data. We went on to decision trees again for categorical data. We went on to random forest again for categorical data. And all these algorithms, so far, we were referring to supervised algorithms. Welcome to the first official unsupervised algorithm, which is called clustering. Okay. Now, remember, just like regression, clustering is a broader term. You have linear regression, you have logistic regression, and so on. Again, clustering is a very broad term. There are various algorithms that can do clustering for you. The algorithm that we are going to see today is something called K-means algorithm, which allows you to do clustering. Okay. But the big question, what is clustering and why is it considered unsupervised learning? Okay. Anyone has any idea of what is clustering? Has heard about this term before? No? All of you are new to it? Yeah, what is clustering?
So something like arranging a similar type of.
That's right. Another kind of records into one group. Okay. Let me give you an example. Let's talk about student data. I have all your data, your age, qualification, etc., etc. And I am asking a machine learning algorithm that can I have three groups of students in this class? Listen very, very carefully. I have all your data. I have 10 columns of your data. I upload these 10 columns and I say, can you come up with three groups in this student data set? I'm not saying based on what? I'm not saying form groups based on age, form groups based on academic performance. I'm not giving any input. The only thing that I'm saying, can I get three groups of students from this entire data? Since I'm saying I want three groups from this entire data, there is no that I'm ready to find out whether student will pass or based on similar patterns, can you find three groups inside this data set? That is the reason why this is unsupervised learning, because there is no one variable that you are predicting, you are calculating, you are estimating. It is forming groups within your data set. Now, why you have to be ultra careful with unsupervised learning? Remember, everything in machine learning, everything is AI, is eventually mathematics, nothing else at the end of the day. Now, what algorithm will do, it will calculate the distance between your marks and age and this and that, and then try and find those which are commonly related, try and find those which are closer, etc., etc. And it will tell you these students are group one, those students are group two, and these students are group three. It will do the job. Now, whether the job was meaningful or not, as a human, you will have to sit and analyze. Remember, the job that the algorithm did was from a mathematical point of view. It does not know that this column is age. It does not know this column is mass. For the algorithm, everything is numbers, right? Based on the numbers, based on the math, based on the Euclidean distance, it has done everything. It has given this is group one, this is group two, and these students are group three. Job done and dusted. My question to you, as a human, how can you understand whether this grouping was meaningful or not? Now, let's say you gave to the algorithm student data, this student data. All of your data I had, I gave it to the algorithm. I said, can you please form three groups? It said, this is group one, that is group two, and all of you here are group three. How would you understand? Great point. Now, as a human, let me first talk about her answer. She says, as a human, you find out if there are any patterns. Okay, show me the average age in group one, show me the average age in group two, show me the average age in group three, and then I understand, oh, there is a difference. Maybe group one can show the academic performance. Compare it to group two, compare it to group three. In group one, show me average experience. Compare it to group two, compare it to group three. I start taking my notes on what is common in group one, how is it different from group two, how is it different from group three. The biggest problem of unsupervised learning is there is nothing you can compare. How can you say this is accurate, right? You cannot say, oh, actually these guys were in group one and it matched. Actually, those guys were in group two. These groups never existed. That's why I went to unsupervised learning. Unsupervised learning did the job. the only way to know whether it was meaningful or not is for you to draw and understand patterns, draw graphs, find out what is common in group one. Of course, the tool will help you. It will say the average of age, educational experience, and academic performance is this for group one. It is this for group two. It is this for group three. So I can understand from what it does, but I would explore more and I would say, are these groups meaningful or purely by mathematics, it has just given me. And remember, it will never say no. This is again the biggest problem of AI. You give a task, it will run it, it will say this is group one, this is group two, this is group three. It will never say, sorry, these are not meaningful groups. You will have to sit down and understand whether this is a meaningful grouping or math has done the job. Otherwise, there is no concept of accuracy. If there is no concept of accuracy, there is one big difference between what we have seen so far versus when we implement this in data IQ. Can anyone tell me what's going to be the major difference? So if you remember, what did we do so far? We had a data. We used to prepare the data. We used to have a training and testing. We used to apply the model on train, test it on test. Now I'm doing unsupervised learning. Where do you think will be the biggest difference when I do unsupervised learning compared to the process that I've seen so far? Sorry? There is training and testing. Okay. Any other guess? What will be the difference in unsupervised learning versus supervised learning from a process point of view? Will we still do preparation? But one by one, will we still do preparation? Yes, there will be some missing values, there will be something, we would still do preparation. Will we do training and testing in unsupervised learning? Why will we not be in a position to do training and testing? Why can't you? You don't have parameters. Which parameters you don't have? We have. So let's say we have age, we have qualification. So imagine we are doing student data. I'm trying to form three groups from your class. I have your age, I have your gender, I have your academic qualification, I have everything. What stops? That's right. And what is the target variable here? What is ultimately trying? The group numbers, right? Now, let me take back examples that we have done. What were we predicting in that data set? You remember which use case was that? So, okay, and for the fact that it survived or not? Yes, it was there. So now it's very easy. You have a training, you have a testing. In the test, ask the model to predict, compare it with the actual answer, and you get the accuracy. We moved on to decision tree. What was the use case? What did we predict in decision tree? Credit card, sign up. Whether a customer would sign up for the credit card or not. Did we have a column which said yes or no? Yeah. So now you have a training, you have a testing. Let the model do the prediction, compare the answers. Now I have student data. I have age, gender, educational experience, academic performance. I have everything, but I don't have that column that says following students are in group one, following rows are in group two, following rows are in group three. I don't have that. It's completely not there. So with unsupervised learning, I'm trying to create that column which never existed at the first go. There was never a column that said they are in group one, they are in group two, you are in group three. That variable itself does not exist. And in those cases, I go for clustering, which is one of the ways of unsupervised learning, where I am doing grouping within the data set. And were these students actually in group two? Were you actually I went for clustering? So there is no testing, no training. You have Otherwise, up to you. Whether it was meaningful or not, you need to find common patterns. If you find good patterns, you would say, yeah, group 3 is really different from group 2. Group 2 is really different from group 1. Next question. Do you find any realistic use case? I would never use student data for doing grouping. In a real industry projects or use cases, where do you think you can form groups of what? Where do you think this grouping can help you? Tradition, we all know a lot of interesting use cases. When you go, what
If we have the window size of property, we can group people among the people who are might be interested on the villa. Might be
very interesting.
Or if you have 1 BHK.
Love that answer. Love that answer. Now, let's say you have a full database of all the people who are interested in property market, all the leads that you have in the real estate company, and now you're saying, can we do some grouping to understand, oh, these set of customers have certain preferences, these set of customers behave very differently, these set of customers behave very differently. And I'm not saying based on what. I'm not saying based only on the villa preference or apartment preference. It could be based on long term. It could be based on off plan versus buying versus renting. I give every data and I ask, can we cluster these people so that my marketing strategies could be very different for group 1. If I find effectively nice groups, it could be very different for group 2. It could be very different for group 3 and for group 4, depending on how many groups you're forming. Fantastic use case. Anything else? Healthcare. Absolutely, you have, let's say, all the records that you have. Can you form clusters? Can you form groups of those records? And again, customer segmentation. Let's say, your company is trying to come up with a loyalty program, and they are saying, we just don't want based on only the loyalty to have gold, silver, and bronze. Maybe we want to find patterns. Some patterns that could lead to one set of customers who are effectively very different from others, you can do clustering. Telecom is a big player in clustering. So all these packages that you see with bundling offers and everything, they actually do clustering and they say what type of people would buy social media at a certain amount. There is another group of people who have their data usage low, but their call volume is high, international call volume is really high, so on and so forth. Again, grouping is a very important concept in unsupervised learning where you're open for answers. You don't know if you will be able to hit it. You don't know if you will be able to find something good, but you want to run the experiment and see.
E-commerce companies such as Amazon.
Very good.
If you select one product, then it automatically recommends with what product you should.
Very good. And in fact, K-means clustering is the algorithm behind recommender system. They actually do clustering, which products are often brought together, which products are not. And K-means is one of the foundational algorithms for the recommender system. In fact, e-commerce is one of the biggest players in clustering. And let me show you one very interesting case study of that e-commerce. Now, long back, they actually published this case study purely by K-means clustering. Now, what they did is they said, we have so many customers who have purchased from our e-commerce website. Let's try clustering. Let's see if we find groups of customers. Let's see if one group behaves very differently from the other group, behaves very differently from the third group. They actually did 4-group clustering. And you can choose. You can choose if you want 3 groups, 4 groups, 5 groups. The K in K-means actually stands for number of groups that you want. Okay. Now, listen to the story. Quite phenomenal. I'll share the whole PDF with you. It's a fantastic case study. They did this clustering and they used K-means. And K-means said, okay, I'll do the job for you. These are the customers in group 1. These are the customers in group 2. These customers in group 3. These customers in group 4. What do you think the company did after getting those group recommendations from the algorithm? What should be the next step for the company? Sorry? But before that, how do they know these groups are really good groups? Yeah, possible. So looking at different variables of group one, comparing it to group two, sorry, frequency of purchase of group one, maybe analyzing it with return rates in group one. Are they different? Are they same? This is what the company did very, very nicely and look at what they found. So here are some interesting graphs. By the way, the colors that you see are the output of the algorithm. Algorithm has already done the job. It has given so many customers in group one, some customers in group two, some customers in group three, some customers in group four. What the company did, they said, let's analyze it in two-dimensional graphs, one by one. They took the first graph. What do you see is on the x-axis? Purchase frequency. How often do consumers purchase? And what is on y-axis? Return rate. Now, the moment they did this for the four groups which the algorithm gave, they found something interesting. And they said, look at the green group. There is something very weird and very different about these guys. What is the common property of group number? They have the highest purchase, but they also have a very high return rate. Now, this is where they started analyzing. They said, oh, this is a very interesting group. At one end, they have features that we like, which is they purchase a lot. But at the other end, they have features that we don't like, which means they return a lot. And now they started this alone, this group alone is a Pandora's box for the company. They said, we can start analyzing the way we want. Number one, we can analyze, are these guys returning the products because of return more, or shall I check historically what products they purchase? Is it returning a lot? That group alone opens exploration possibilities for the company. They would say, I would love to investigate that group. Why are they returning a lot in spite of the fact that they are purchasing a lot? And you can see that green group behaves very differently compared to the other three groups. The moment you see that graph, which is showing some exhibitly some really different characteristics compared to the other groups. Let me one more interesting group, the red group. There's something interesting about these guys. Return rate is very low, and also it's not very much variable in the return rate. If you see, all of them have pretty much return rate. With the second graph. Now, return rate comes on x-axis, and the monetary value that they bring in comes on the y-axis. Now, you would say that green group's monetary value is probably the lowest compared to all the others, which is explanatory because they return a lot, so they get the refunds, and the monetary value goes down. However, one thing interesting to note is this group as well. Group number 4. Now, these guys, purchase frequency is the lowest of all the customers. Okay. What about their return rate? Is that favoring the company or against the company? Favoring, fairly okay. Not of course, slightly higher than the red group, but still much lower than the green group. Now, imagine how company is thinking. They are saying these people have the lowest purchase frequency, very good in terms of the return rate, but the monetary value is pretty good. In fact, even higher than the red guys. Yes, exactly the kind. There is a word given in business terms for the company. This is cash cow. They would say, oh, these are the people who buy less, but their pocket size is pretty high. And because their pocket size is high, the overall monetary value that they bring into the company is way higher. And Trust me, this was a gold mine for the company. They need to do, we need to target to shift over there slightly here. Why?
Small ticket purchase will give up.
The small change in purchase frequency because of the big pocket items could actually lead to significant impact in the monetary value, which is what the company did. They said, let's do very targeted promotion. They are like premium customers for us. Let's try and make sure that they purchase a bit more, not too much more, a bit more, so that our monetary value can be impacted. And they just published the whole case study. They also about these guys. And they said, they are returning a lot and we are losing money because we are giving them a refund straight away. Let's stop that policy. Let's introduce cash coupons as the first level and say that, okay, you have to return the product if it is for here's 100 that buy something else on the same website, which means not losing that monetary value, keeping the monetary value within the firm itself, so on and so forth. They did practically everything they could do for group one, for group two, different marketing campaigns. It's a nice case study. I'll share that with you. But remember, all the drama happened after algorithm did the job. And that's the most problematic part about unsupervised learning. Algorithm is not complicated and it's very easy. You click a button and it will form the groups for you. Whether those groups were meaningful or not, that's a post exercise challenge that everyone will have to sit and analyze, do pivot tables, do graphs, try and find the patterns. That's not where the algorithm helps you. It only helps form groups and clusters.
So it's used like real world companies, so they're from like
This was real world. This was a property commerce company in US and they published the whole case study. So this was a real world exercise. They did K-means itself. They mentioned the algorithm also. They said we implemented K-means, we took four groups, we asked the algorithm to give us four groups of customers. They gave all the graphs that they made. These are the graphs that we analyzed completely.
what's the company name?
I forgot it was, and now that company even does not exist. And you can actually imagine it was an old company because now pretty much every company has the cash, I mean the coupon kind of system where you don't directly give the refund. If you want, you get, but then they encourage that you have those coupons. That time it did not exist. I'll share the PDF. I'll share it on my learning center. Any other question before we see something interesting about the implementation? Shall we go ahead and implement in Data IQ? Okay. Let's do this. So once again, those who came late, in week 6 folder, there is this iris dataset, iris.csv. And I would recommend doing this in your new Data IQ license, not the MDX one. So you get comfortable with the Launchpad. Let's create a new project, call it unsupervised. It's a fun data set that we are going to take for unsupervised learning so that you understand how amazing the algorithm is. Everyone, please load the data on your screen. Need any help? Okay, so no, for part one. Okay, so then you continue with the make a project here and download Iris and bring it. Is everyone with me? Shall we get started? Okay. Now, here's a very interesting data set, but I would issue a warning here. The way we are going to do this is not truly the real use case of the algorithm. Let me explain why, and please listen very, very patiently. Now, take a guess on what do you have in each row? What is row 1, row 2, row 3, row 4? It's a flower data set. You have flower 1 in row 1, flower 2 in row 2, another flower in row 3. You have the dimensions of the flower, sepal length, sepal width, petal length, and petal width. Last column, you also have one critical piece of information, which category of flowers it is. Okay. Question to you. Can you quickly analyze the species and tell me how many categories are there and how many flowers are there in each category? Fantastic. That's the response I want. 3 categories. Which are the ones? Setosa, versicolor, virginica. And how many in each? So total 150 flowers. Okay. Now, please listen very, very carefully. And why I'm telling you this is not the ideal way to do unsupervised learning. We are just trying to have some fun here. And what is the fun is we are trying to see, can mathematics and AI understand nature on its own? Very quickly. What I'm going to do is I'm going to use clustering and I am going to hide the last column. I will not give this as an input to the algorithm. I would say, boss, you need to do unsupervised learning, but you have sepal length, you have sepal width, you have petal length, and you have petal width. Only 4 columns to play with. Okay. Using these 4 columns and 150 rows, can you form 3 groups of flowers purely by the dimensions? I'm not going to tell which category they actually belong to. Purely by the dimensions, can you tell me, okay, so and so row is in group 1, so and so row is in group 2, so and so rows are in group 3. Okay. And then what I would do is, okay, unsupervised learning has done the job. I also know the groups. I know that 50 flowers are in group 1, another 50 flowers are in group 2, another 50 flowers are in group 3. From a mathematical perspective, to understand the nature itself. Now, here is my biggest question. If you are able to answer this, you understand unsupervised learning. Why do I say this is not an ideal context of unsupervised learning? These are there and you know what groups are there, you would never do unsupervised learning. Unsupervised learning should only be done when you don't know the answer, when you don't know the groups, you want to explore, you want to understand the patterns, and only then unsupervised learning can be applied. But we are tweaking the version of it. Let's assume that these species are there. Let's assume, let's try and run, see what is group number 1, what is group number 2, group number 3, and then match it with the species later on. But again, reminding you, not the ideal way. In this case, you already know the answer. You shouldn't be doing unsupervised learning, but just to see how good or bad the algorithm is purely from a mathematical point of view. Shall we do this? Okay. So, first things first. Do we need any preparation, any missing values, first of all? No, everything is perfect. Let's look at the data type, stored as string, interpreted as decimal. Ideally, I should do stored as decimal and stored as float or double also, but shouldn't be a problem. These are categories, so shouldn't be a problem. I think all good. No preparation needed. Okay. Let's go back to the flow. Okay, so no prep needed. I mean, one step is gone. Do I need training and testing data set? No, there is nothing like 80% of train, 20% test. This is not supervised learning, so we are not getting into that, which means you're actually ready to run the algorithm. That's how simple it is. And that's how it is. Unsupervised learning is simple. You have your data, there is no target variable, nothing that you're predicting. So just take the data, go for lab, and let's figure out where is that option of unsupervised learning. So let's do this. Let's click on Iris. Let's click on lab. Tell me. Auto ML clustering. Now, no predictions. You're not doing any prediction. You're not saying predict this, predict that. It's a different type of AI that you're doing. Let's go for auto ML clustering. And again, I told you there are various algorithms that can do clustering for you. K-means is one of them. Interactive clustering is another way. Anomaly detection is another way. There is something called hierarchical clustering as well. Lot of different methods. As far as you know, one of the methods, you're good. Other you can try later. K-means is selected by default because that's the algorithm everyone usually fundamentally tries. So no need to change anything. K-means is already selected. Give a name to your analysis. And let's click on create. So this will take you similar tab, design and result. Everything is, there's nothing potentially. Let's go to design. And whole data. Yes. So sampling method, I wouldn't want any sampling. So anyway, it wouldn't do, but still to be on a safe side, we would do no sampling. Let's go to features handling. Now you see ID is switched off by default. Doesn't make sense to put ID into clustering, but there is one more thing which will switch off. Which is the hiding from the no, we will not make your life easy. We are not going to tell you which category do they actually belong to. That's for us to check how good the algorithm is. So essentially, we will have four things: sepal length, sepal width, petal length, and petal width. Only four things should be switched on. Anything else? Let me check the algorithms. Oh yeah, very important. Now click on algorithms. Now you see the kind of algorithms that it recommends. It's not telling you logistic regression. It's not telling you decision tree. So the tool is quite good in understanding what you want, what are you doing, and recommending the algorithms. All of these are actually clustering algorithms. If you're interested, you can try, few more to see whether other algorithms do better compared to k-means. But for today, we will switch on only k-means algorithm. Now, very important. What do you think this is? What is number of clusters? Number of groups. How many groups do you want? And this is where again data IQ becomes so interesting. It says try with 3, try with 5, try with 7. I can do everything at one go. This is pretty much the tool boasting on its own. Because if it was coding, you would first try with 3 groups, then again try with 5, and then. But here we have a definite objective. And what is that objective? How many groups do we want? 3. So we'll switch off the other options. We will say, sorry, don't do 5, don't do 7. 3 is already there. I want only 3 groups. Okay. But yeah, in a truly explorative stage, which is the real use of unsupervised learning, you would want, I mean, if it is number of customers, you would say, okay, try 3 groups, give me also 4 groups, give me 5 groups also. I will see in which case, more meaningful groups are formed, and I can take it forward. So in an explorative stage, that option was quite good. You can mention how many groups you want, and you can see all the results at one go. But today, I have objective in my mind, so I will keep the number of clusters as 3. What else? I don't think anything else is required. Let's click on save. Let's click on train and give a name to this as trial 1. All right, so let's do the interpretation first. You get the outside results. One big caveat, this is not accuracy. There's no concept of test and train, which in logistic regression and decision tree, you look at this number and say, oh, this is accuracy. This is nothing, no interpretation over there. Unsupervised learning doesn't test anything for you. It hasn't tested it on species data or anything. It had only 4 columns. It did 3 groups for you. Again, this is not saying that cluster 0 is more important, cluster 1 is less, nothing like that. So it is just a common way of showing the, it shouldn't do interpretation at this point of time. No accuracy, no feature importance, because that's not the objective of what we are doing. The only thing what we are doing, we had 150 flowers. Some of them we want in group 1, some of them we want in group 2, some of them we want in group 3. If you want to see what actually happened, let's click on k-means and go inside the actual trial results. And now you see some important answers of k-means clustering. So it says, I did the clustering for you. In group 1, there were 50 flowers. In group 2, which is cluster, there are 56 flowers. In group 3, there are 44 flowers. Remember, your names of clusters could be different because anyway, they never existed. It could be group 1, 2, 3, it could be 0, 1, 2, 2, 1, 0, whatever it is. They never existed at the first place, but it did form 3 groups for you. First group has 50, second one has 56 flowers, and the third one has 44. Now, have a look here. This is where the tool is so brilliant compared to coding platform. In a coding platform, it would have done the job and stopped over there. But here, it has started giving you some knowledge also. It says petal length is an average 61% smaller and mean of 1.6 against the global so and so. Petal width in cluster 0 is 79% smaller compared to global and things like that. And when you click on the next cluster, so have a look, cluster 1, also it gives you some interpretation. Cluster 2, also it gives you some interpretation on how cluster 2 is a bit different from cluster 1, is a bit different from cluster 0. All these insights are quite interesting. Also, you can name these groups. Let's do that. So cluster 0, I will rename this as group 1. Cluster 1, I will rename this as group 2. And cluster 3, I mean, cluster 2, according to DataIQ, is group 3, so that I don't get confused with the names. So I gave my own, you can say G1, G2, G3, you can give 1, 2, 3 if you want. I have just renamed them as group 1, group 2, and group 3. Now, if you see clusters and if you see heat map, it is drawing the maps already for you. It will say, okay, if you look at group 1, this is how petal length behaves, this is how petal width behaves. Blue means low and red means high. So in group 1, petal length and petal width are considerably lower than group 3. So purely by colors, you can start understanding the differences between group 1, group 2, group 3. All this is fantastic piece of information. You can have cluster profiles. You can choose. And again, this is brilliant from the tool. Imagine for everything in coding, you will have to draw a separate graph. You will have to do this. Here, everything is done for you. Just choose which parameter you want, see the graph yourself, understand whether grouping makes sense or not. All this is available at your disposal. And you can have as much information as you want about your group. Okay, now Very, very important. All this is great. You have given me all the information about differences and all that. What I am keen to see is where did you add that column where you said these rows are group one, these rows are group two, and these rows are group three. Can you tell me where do I check that? Predicted data, absolutely correct. Let's go on that. So this is all report, which is great value added information, but my real stuff is here. Predicted data. And you see the magic that it has done. It has actually added cluster labels for every single row. And look at the damn accuracy of mathematics. It is unbelievable that purely by math, if it can understand, which category the flowers can belong to. Of course, there are a lot of errors. I'll tell you where the errors are. But first impression is mind blowing. Look at this. All the Setosa flowers almost are captured into group one, and so on. Let's have a look at full thing. Looks pretty good. Is mixed between group 2 and group 3, and also some. Okay, now here is a task. Let's see if you can achieve this. Question? Nothing. Nothing. So it's just groupings having done by mathematics. And everyone, let's see how good you are now. Imagine, and this is a data IQ task. So nothing related to unsupervised learning. Now you remember this confusion matrix sort of a thing that we saw in logistic regression. I want you to do something similar. I want you to make a sort of table. I don't know how you will make that table, where you say, okay, Setosa flowers, Versica, whatever it is, Versica and Virginica, and how many of them actually were classified as group 1, group 2, and group 3. 3 cross 3 table of the flowers versus the group prediction. Where can I make such sort of a table? All right, good. That's great option to begin with. What do I check? Pivot tables. Nice. Let's do this. Pivot tables. What do I put in rows? What do I put in rows? Okay, let's see cluster labels in rows. What do I put in columns? Species. Good. You guys are good. Okay. And values? Count of records. Let's try this. Actually, we can reverse it. If we reverse, it will be much better interpretation. Let me put species in rows and cluster in columns. That gives me a much better idea. So I've just swapped the rows and columns and look at this mind-blowing thing. In Setosa, there were a total of 50 flowers, and all 50 of them, all 50 flowers got clubbed into group 1. Massive, massive win for the algorithm. In Versicolor, total of 50 flowers were there. 39 of them got clubbed into group 2, and only 11 misclassifications into group 3. Virginica, there were 50 flowers. 33 of them got classified into group 3, only 17 misclassifications. So out of 150 flowers, how many flowers did it wrongly assign to the group in total? 17 plus 11, which is 28. That's it. Purely from a maths point of view, it was able to analyze the petal length, petal width, sepal length, and sepal width. And without us telling which group do they belong to, it did a very, very good job of clustering, and it gave us mind-blowing results. And again, as I said, in this case, I was just experimenting. I knew the results. I would actually not use unsupervised learning, but I just wanted to check how good this k-means clustering algorithm is. How can this be a part of your hackathon? Imagine you are doing your prediction model and everything. The last task can be that can you divide your customers into 3 groups and tell us whether you found any meaningful groups or not. That could be one of the tasks. So you did your prediction model, you did logistic, you did everything, you did a use case. The last task is after that, can you have 3 groups of customers? So whatever data is there, you subject that to unsupervised learning, you get the groupings, make sure you know where to check the grouping. It's always in predicted data, and make sure you know you can label those groups as group 1, group 2, group 3. In another case, you can say customer group 1, customer group 2, customer group 3. Label, see the output, and then go to charts and see, or you can even analyze it from here. So if I do cluster labels, analyze, you can see how many were in group 2, how many were in group 1, how many were in group 3. This is questions. Let's look at cluster ID. 56, 50, and 44. So basically it's the same. So group 1 corresponds to 0. Group 2, it's the same, exactly the same. It's just that they have given an ID of 0, 1, and 2. That's it. So it's just a good added feature to have, nothing different. It's exactly the same as group numbers. Yes. Correct. That's correct. So because it is approximate, so it can never be accurate. Clustering. So for example, if I ask, these are student groups, it can never be accurate that it will give me this is group 1, 3. Clustering itself, now guys, very, very important question. Remember, the purpose of clustering is never accuracy. For example, you have 100,000 customers with you, and you're saying group 2 can we get some common patterns in group 3? There's no question of accuracy. You cannot say, oh, group 1 people should have been in group 2, group 2 should have been in group 3. In this case, we can, because we know the final answer, and that's why I gave a warning. You should never use unsupervised clustering for this, because in this, if you already know the answer, if you already know the answer, why doing the algorithm, right? That's the big question. In a customer data set, you would never know. You're saying to see 3 groups. I will try and figure out if there are some common patterns in group 1, some common patterns in group 2, some common patterns in group 3. You can never say, was it accurate? Was, group 1 guy should have been in group 2? You can never make out. That's why it is unsupervised. There is no target variable, there is no prediction, there is no accuracy. You are exploring from the data. And on 100% of the cases, you never get accuracy. You never target 100% accuracy.
What we done is now, right? This is that we got the job except for the group one.
No, so that's what I'm trying to understand. Make you understand. This was not purpose. So I was not trying to say whether the algorithm is 100% accurate or not. What I'm trying to say is, if it is forming groups, is it still capable of forming meaningful groups? That's the only thing. And there is meaningful group. You have group 1, which behaves very differently from group 2, very differently from group 3. Obviously, you cannot expect math to pinpointly say, okay, these will be setosa, these will be versicolor. We never get that as an input. It's an approximation. That's why it is unsupervised learning. We are just trying to find patterns. And I knew this could be a confusion. So once again, I repeat, the purpose of today's exercise was not to compare accuracy. Never. In fact, this is not even a great case of unsupervised learning. Ideally, imagine you never knew Setosa, versicolor, and virginica. You never knew they existed. You say, okay, these are the flowers. Do we have some common patterns? Something in group 1, something in group 2, something in group 3. And you would say, oh, in group 1, they have larger petal length sepal length. They have small length and sepal compared to the other group. So we are exploring features, we are exploring patterns, and that's why it is unsupervised learning. Make sense? So you're right. I mean, technically it's not 100% accurate, but that's never the objective of what we are doing. We just wanted to have fun with the algorithm to see is it capable of at least forming meaningful groups, which definitely it is more than capable of doing that. Any other final questions? Yes. Unsupervised learning. And I say, can you form 3 groups of accidents? And then I understood that certain events which have happened, they reveal a particular pattern. In those, the temperature humidity was this, and it led to a more fatal accident. And you would say, wow, that's an interesting pattern. In another group, the temperature was lower, humidity was higher, but the casualty was less, let's say. And you would say, oh, that's again an interesting pattern. So you try and understand with the help of if it forms meaningful groups. So if your objective and one of the objectives is can I have meaningful patterns in my data? For that objective, you can do unsupervised learning. But if it's not one of your objectives, you might not want to do unsupervised learning at all. Just do random forest distance tree logistic regression for whatever you're predicting. So it depends on your objective. And now you should be able to so to everyone, very, very important. I said the minimum mandate in coursework 2 is your two algorithms. Either you can do another algorithm for unsupervised, which is another objective. That's your wish. Or you can do both for the same objective. So 2 algorithms is what we want. Whether it fits in some context, it might not fit. If it's not fitting, you're not seeing grouping is in any good objective. You might ignore it.
So this trophy number is shown. So it will match in the
The time of execution. Multiple if it's showing which case it took the least time, and that's it. So it doesn't matter. That number doesn't matter at all.
but in supervised
It's supervised it matters because that's your accuracy of the model. Yes, definitely. Anything else that I can clarify? All good. So all of you are now confident on the new data IQ accounts for the next 2 weeks. You'll be using the same. Get comfortable. It's called Launchpad link. Your personal email ID and password. Private. It's not discoverable. Remember, in mock hackathon as well as main hackathon, the main data IQ link of the university will be disabled. So you will not have access to that. You'll have only access to this one where you will be completing your hackathon.
So can we get those projects and give us?
There is a way to export it to zip in the personal account. I wouldn't recommend that because personal account is only for 14 days. So actually, it should be the other way. From your personal account, you should switch it back to the data IQ account. So this will close in 14 days. It's mainly for the hackathon. Sorry. Only because there is no, again, that's a good question. In a supervised learning, we usually deploy so that we can get an unknown data set, pass it through the model and get some predictions. Here I got what I wanted. So ideally you can, but there's no need. If you got what you want, you can. Next week. Yeah.
With your customer data. Sorry, data IQ sorted into groups for me.
Correct.
So I should understand that there is a relation in these groups.
Mhm.
And I can classify myself. I can understand it in group.
You can understand it yourself.
That is objective.
Yeah, but data IQ gives you some parameters. So for example, now if you saw the models, go to visual. Yeah. So for example, when I see the thing itself, you see heat map. Now data IQ itself is giving you some hint. So it's saying, look, this is low and this is high. So I would say, oh, in group 1, what is happening is the length and width is lower compared to this as compared to group 3. In group 3, all these are higher compared to the sepal width. So, from the heat map, I can understand. from cluster profiles, I can see the graphs and understand. So a lot of the things you can understand here itself. But thank you. But if you want, you can draw additional graphs and see if it is moving.
So like if we only choose like 3 groups.
Correct.
So if like, there were like 7 groups.
Correct.
Groups,
Hmm.
give us like 8 options.
Yes, and that becomes very complex. So people generally don't do 8 grouping, 9 grouping, 3, 5 are usually the ones, 3 to 5. Yeah. Because beyond that, then there are 2 small patterns in group 1 and very different patterns in group 7, very different patterns, unless there is a requirement that you need to break it into 9 groups. Otherwise, you wouldn't do 9. Yeah, good question. Online students, any questions? Dipayan, go ahead, please.
Sir,
Hi.
yes, sir. So those tasks can be later.
Done, done. The class is done. Thank you so much.
Fine, sir.
Sir,
Thank
I
you so
just had
much,
a
sir.
quick question.
Go ahead.
So, for the coursework, we're okay to do it on the student data IQ. That's fine.
Yeah. So in coursework, I wouldn't recommend this trial license.
Okay, got
Yeah,
it.
just do it on your
And,
regular MDX student one.
got it. And when we're done with the work we're doing, like in a hackathon or so, how do we how are you assessing it? Is there a way to extract this data, or are you
No need to do
assess-
that. So I'll tell you once we do the mock hackathon. So basically, my question, and you would say question number 1, you did data preparation, give a screenshot of that. So you just take a screenshot, put it in the Word document. So you don't actually upload your data IQ file, you upload the screenshots which are needed.
Got it. And just to confirm once again, we can use our personal laptop or devices for the
100%.
hackathon, right?
100%
Okay.
yes.
Okay, thank you so much.
All right. Yes. Oh, so this dashboard was not there, right?
Yeah, this was not there.
Nice. Interesting, and it gives a summary of everything.
And all, and here is your. These are in working right now because
Okay.
there are some API problems that
Okay.
I'm facing.
But very good overall interface. Nice.
I'm planning this for the AI hackathon.
Oh, AI hackathon.
Yeah.
But do you have a theme in AI hackathon?
So yeah, they have given that for a business problem you have to decide.
Okay.
So this is also one.
Okay.
And the JavaScript one I just told you. We did this to that. Okay.
Nice. Good job.
So, just QR code for the attendance.
Attendance, sure.
Yeah.
Thank you. See you. Yeah. Do you want the QR code or manually? Okay. 1 minute, I can just put it in. Okay.
Thank you, so.
Thank you. Yes, I will be posting that. Yeah, with the links and everything.